Now it's time to talk about the IP protocol, the network layer protocol in the TCP/IP protocol suite. The IP protocol is the principal communication protocol in the TCP/IP protocol suite. It's the protocol responsible for the two functionalities of the network layer, the addressing and the routing. It defines the addressing to label the datagram or the packet with source and destination addresses, source and destination logical addresses that are called the IP addresses. It relays the datagrams or packets across the network boundaries from the source to the destination depending on the route, which is established according to the source and the destination IP addresses. This routing function enables internetworking and essentially establishes the internet. Without routing, it's hard to imagine that there is internet here. This routing delivers packets solely based on the IP address in the packet header, solely based on the source and destination IP addresses that are added at the network layer in the form of a header to the data in this layer. The IP protocol structures packets and encapsulates the data with the source and destination IP addresses to be routed and delivered over the network. What is the IP address? The IP address is the logical address that is depending on the geographical location of the machine. It's unique. It cannot be repeated over the internet. Each single machine over the internet should have only one IP address that is unique. It's logical and not physical, which means that it can be changed according to the geographical location of the machine. The length of the IP address is 32 bits or 4 bytes or octets if you call it like this. It's version 4 of the IP address that is 32 bits. Version 6 of the IP address is 128 bits. Each byte or each octet ranges from 0 to 255. This means that each byte is representing 8 bits and each byte can take the number from 0 to 255. The IP addresses are categorized into classes. We can see class A or class B or class C or class D or class E IP address. Each IP address identifies single machine, and each IP address, if added as a destination to a packet, is used for routing from the source of the packet to the destination by the routers. It is read and interpreted by the routers, which read layer 3 information. The classes of the IP address, and let's focus on the main three classes A, B, and C, has the ranges according to the number in the first byte, the first octet. If the number in the first byte ranges from 1 to 126, then it is class A. If it ranges from 128 to 191, then it is class B. If it ranges from 192 to 223, then it is class C IP address. According to this classification, there are possible numbers of hosts for each class. Class A supports up to 16,777,214 machines. Each Class B category can support to 65,534 machines. Each Class C can take 254 machines only. The public IP addresses that can be given to machines to exist over the internet. In Class A, it can be from 1.000 to 9.2555 and 2.255.255. It is read like this: 1.0.0.0 to 9.255.255.255. Then we skip the number 10 and move to the number 11 to the number 126. Note here that from class A to class B we have skipped the number 127, and class B ranges from 128 to 172, and the range inside 172 is also have some numbers skipped. You cannot see 172.16, for example. 172 192.15, then 172.32 till 191.255. Then we start from 192.0.0.0 to 192.167. Then we skip 192.168 and start again from 192.169 to 223.255.255.255, and here ends the class C, where starting from 224 starts the class D, and the class D is for the multicasting addressing. The private IP addresses that cannot exist over the internet as real IP addresses, as public IP addresses, and can exist only inside local area networks are these ranges. In class A, every IP address starting with the number 10. In class B, it's every IP address having from 172.16 till 172.31. In class C, it's any IP address starting with 192.168 to 192.168.255. Any IP address starting with 192.168. These are the ranges of private IP addresses that can be given to machines inside a LAN and then connected to the internet through some technology that is called the network address translation or netting, to give many machines having such IP addresses, such private IP addresses, one real IP address to be contacted through over the internet. This is to save the IP version 4 addresses that has become scarce resource over the internet and allow for more security during the communication with the machines having private IP addresses over the internet. There are some reserved IP addresses. You can note now that the IP address is divided into two parts. The left part defines the network. The right part defines the host. So if the network address is a specific number and all the host address is zeros, then this is the network address itself. And this IP address cannot be given to a single machine. It defines the network itself. It's an entry inside the routing table that we are going to talk about lately. The broadcast addresses is composed of network address that is specific, and the host is composed of all ones. This is used for broadcasting and cannot be also given to a specific machine. It is reserved for broadcasting. So if we see an IP address that has the network address with a specific number and all the host address zeros, then it is a network address. Or if all the host address is ones, then it is a broadcast address and cannot be given to a single machine. Devices working on layer 3, devices working on the IP layer are the router and layer 3 switch. The router and layer 3 switch are the devices that redirects packets between networks. They forward packets based on the destination IP address and according to the routing table stored inside the router or layer 3 switch. According to this routing table, the packet is investigated and is searched for the path that it should take based on its destination IP address. The router looks at the destination IP address, searches the routing table for the right path, then forwards the packet according to this path found in the routing table. Let's have a rule here. The network ID equals the IP address ANDed with the subnet mask. If we have a given IP address and a given subnet mask, the subnet mask is something that masks the IP to get the network ID. If we AND them together, this is a logical operation that is done between ones and zeros and called ANDing. If we AND them together, we can get the network ID of this IP address. Routers are protocol dependent. They depend on layer 3 protocol. Layer 3 switch differs from a router that it is super fast than the router. It is completely hardware and uses hardware in routing. Meanwhile, routers can use software such as the routing tables to be used in the routing process. What is a routing table? It's a table that is stored inside the router or layer 3 switch. If inside the router, then it is software. If it is inside the layer 3 switch, then it can be stored in a hardware form or a firmware. It is composed of rows that are read sequentially. Each row is composed of several columns. A column for destination network, a column for subnet mask, a column for the interface that is connected to the router and that is used for forwarding the packet, a column for the gateway. The gateway is the next router. It is the next hop for the packet to go through. A column for the cost or the metric of the path, and it is used if there is a certain path that is an alternative path to the main path of this packet. So they are compared to each other in the point of view of cost or metric, and the less cost, the less metric is chosen for this packet. The routing table can be built statically through the network administrator, which store this routing table inside the router, or can be built dynamically through some dynamic routing protocol such as the RIP routing information protocol or the OSPF open shortest path first dynamic routing protocol. The destination network can be dedicated or deducted from the destination IP address through ending with the subnet mask. According to this, we can know the interface that the router is going to choose for forwarding the packet and the gateway that will be the next hop for such packet to go to. If we want to see routing in action, we can look at this diagram. We can see the host source and the destination host separated by 3 networks and 2 routers. Each source connects to its specific router through indirect delivery, then the router connects to the next router through indirect delivery, and then the last router connects to the host through direct delivery. We can see that each 2 machines connected through the same network uses direct delivery. Routers contact each other through indirect delivery because they are not connected directly through the same network. This is routing in action. We can imagine that this host machine is in a country and this destination machine is in another country where an ocean can separate them, but packets can go through these routers from the host to the destination according to the routing table, according to the path chosen by the routers to be delivered from the source to the destination based on the destination IP address. Thank you.